In this next lesson, I want to take a little look at the foreach method. And while we're looking at foreach, we'll also start looking at anonymous functions in Scala. Foreach is a method that we call on sequences. So if I create a little list here, and I will do, how about we make a variable named int, and we'll say that is a list of 1, 2, and 3. Then I would run for each, like, now the thing I'm hesitating about is I want to show that foreach is used for side effects. So we say inst.foreach, and for each I, then I want to do a print line on I. And you could see that that prints this output. An interesting part about for each is that it's the same as if I had done this. So I could say for I in ints do print line of I. And these two approaches here and here are equivalent, and you can actually imagine the body of the for each method being written just like this. It's implemented as a for do loop, or what we call a for loop, and then you would pass in this function here as an argument, and I'll show that in just a few moments. An important part about for each is that this part that I'm highlighting here is an anonymous function. And you can write that in a longer form. Nobody really does this anymore, but you can say I colon int. And let me just put a little space there so you can see what I'm doing. I'll put one at the end as well. And again, the way you would read this, this part here is an anonymous function, and it's saying that for each is going to give me one variable at a time, one int at a time, and then I'm going to transform that into a print line. I'm going to print each int one at a time as they're given to me. And while I showed this syntax here, again, just to be clear, I'm just showing that more for historical reasons than anything else. We don't do that anymore. We would just do this. And the reason we just do this part here is because both you and the compiler are smart enough to say, you know, ints is this collection. It's a list of integer or int data type. So there's no reason to re-specify that right here like this. And Scala just lets us say, you know, just this variable name right there. So you can name that anything you want. I just happen to call it I. And let me clear the screen here so we get back to this. So there's that example. And in this example, we actually wouldn't even do this. What you can do with Scala is you can get rid of that, and you can replace the variable with an underscore like that. And that again gives us the exact same result. And this is a shortcut. This little underscore right here is a shortcut that we can use in certain situations, and I'll talk about those more in just a few moments. And actually, in this particular situation, we wouldn't even do this. We get rid of that, and Scala lets us just write that. So as a summary, I showed this first example just for historical reasons. And then if I go back here, this is something that's perfectly valid, and I did this a lot when I first started working with Scala. And then, once you learn that you don't need to do that, you might start doing this. And then in this situation, as I mentioned, you don't even need the underscore. So we just do this last part here. Now, a situation where you can't use the underscore is when you're going to be referring to the variable multiple times on the right. So I'm going to give a little space there. And as an example, if I wanted to print the value twice, let's say I would just do, I want to do underscore plus, and then that, so plus underscore again, close that parenthesis, close that parenthesis. So what I'm trying to do here is print each value twice, one time here and one time here. And you can see the compiler is like, good golly, Al, what are you trying to do? And this is where you need to use a variable name. So we'll go back, I called it I before, let's just call it X so you can see something different. So I'll transform. For each is going to pass me one X at a time. and I'm going to say x and x there. And I'm not too worried about that deprecation warning. I just wanted to show that when you need to use a variable multiple times over here on the right side of the transformer symbol in this territory over here, you will need to use a variable name. Otherwise, you'll get whatever this nasty error is up here. Now, as for the rules for how this works, I described that on this web page. And this page is based on one of the recipes from the first edition of the Scala cookbook. Here I start by creating a list using its range method here. And that creates a range, I believe it creates a range from 1 to 9. Actually, it uses until instead of 2, so I think it's actually 1 to 9. Well, actually, I can just do it this way here. Copy that, go back to the terminal and put that in there. So yeah, that goes from 1 to 9. And that's one reason I don't talk about this method too much, because as I've mentioned many times before, I don't like the until approach. I would prefer that this was actually 1 to 10. But skipping all that, what I do in this part here is I'm passing in an anonymous function to the filter method to create a new list that contains only even numbers. And again, as I mentioned in the first edition of the cookbook, I actually use this syntax here where I specified the variable type. And I show here in the REPL that this works as expected. And then the important part is that the code that I was passing in there is this thing, and it's called a function literal, or also it's known as an anonymous function. And I believe that this nomenclature is consistent with any programming language that supports this style of coding. And then I mentioned the same thing that I just talked about here, is that even though this code works, it's the most explicit form for defining a function literal, and thanks to several Scala shortcuts, we can simplify it to this, in this case. So here we need at least the underscore because we're referring to this once over here in our anonymous function. Again, this is the anonymous function part right there, and we are using the underscore once. And now in the discussion, I break this down into the rules, basically, of how this works. So the original function literal, or anonymous function I wrote, was this one here. And one thing to mention, if I haven't mentioned already, is that this little guy, we refer to it as the transformer symbol, because it transforms the thing on the left here into the thing on the right here. So in this case, it's transforming an int, or an integer, into a Boolean value, because it's saying if the I modulus 2 is equal to 0, so that's going to return a true or a false. So now we get into the reduction part. So this is the most explicit form, which I showed earlier. And because the Scala compiler can infer that, again, that I is an int, there's no reason to specify that. So now we just have I here instead of the I int up there. Then you can use a wildcard, the underscore wildcard character, instead of a variable name when the parameter appears only once in your function. And so I reduce this code here to just this right here. And now when I get back to our print line example, again, I start with the most literal or verbose form. And again, the int isn't required, so we get rid of that. And here I actually show parentheses. And you don't need parentheses, especially when working with a list. So you can get rid of those, and then you reduce that to here. And to be more precise, I should read what I'm writing here and just say, because there is only one argument, you don't need the parentheses in this case. Where you would need parentheses over here really is if X was a map, and your map is passing over key and value pairs. That's when you would need parentheses over here. And then the next rule is because I is used only once in the body of the function, right here, this is the body of the function on the right side of that transformer symbol. So I is only used once right here. So then we can replace that I with the underscore character, as shown in this example here. And then our last rule is this one here. So it says if a function literal consists of one statement, and so this is our function literal here, and it's just one statement. It's not a multi-line body over here. It's just one statement. So if it's just one statement, and that statement takes a single argument, you don't have to explicitly name and specify the argument. you can get rid of that underscore, and then you're just left with this right here. So I just wanted to show these rules, and if you ever need them, just come back to this web page and you can refer to them. The next thing I'd like to show while we're in this neighborhood is that in the previous examples I showed, all of these guys here were anonymous functions, and that's kind of why I use this long form here, just to show you that more explicitly. And the thing I want to show next is that instead of using an anonymous function, you can also pass in a real function. So I'm going to create a function, and we'll just make this function work with this particular for each. So I'll just say print and int is what I want to call it. So I'm going to take an int parameter, an int input parameter, and then I'm going to return unit from this function. So if I haven't described this already before, def is a keyword we use to create a function. This is the name of the function. And then I'm passing in this one input parameter into the function. And this guy here is the return type from the function. And that's whatever type the body of the function is going to return. And it's going to be unit because all I'm going to do over here is call printline. And that's what printline does. It has the unit return type. And I'm just going to pass I into it right there like that. So that defines a function. And now I can just go back to int, and I can say int.foreach. And again, you have the same rules. So you can say print and int. And that, by that I mean the same reduction rule. So I can call it that way. And I could call it this way. And I can call it this way. So that's pretty cool, right? Here we use an anonymous function. And then here I define our own function. And then I use it in all the same ways. And I call this, I was referring to this as a real function or a real named function. And that's just because I've given it a name. You can actually think of this little anonymous function guy as being just floating around in the universe, and it just doesn't have a name. And then I use it as basically the same body. That code there is basically the same as the body over here. And then I just give it a name. And then I use that name in these examples here. So that's the basics of for each, and now I kind of want to go into bonus territory. And I don't know if this is going to be a little too mind-blowing because we're just in the introductory course. But when I started this lesson, I noted that int.foreach was basically the same. I'm going to have to type that over. So int.foreach printline. And then I noted that that is basically the same as for I in ints do printline of I. And then I said that the for each method here, so for each is a method here that's defined in this case on the list class. It's also available on the sequence class, SEQ. It's on the vector, it's on index seek, it's on the map, it's on a set, etc. Different implementations for each are methods available on all of those different types. And so what I said earlier was that this for each method is probably implemented like this. So to demonstrate what I was saying, I'm going to go ahead and create my own for each function. And because this is a standalone function, the first thing it's going to need to do is take in that list, which would be, I'll call it x of s. That's safe for what we're doing here. And I'm going to make it a sequence of integers. And a seek is a little higher up on the class hierarchy than a list. So by declaring this as a seek, it lets me take in a seek, a vector, and a list, and array buffer, etc. So that's the first input parameter. And the second input parameter we need to pass in is actually this function. So now what I'm doing is I'm writing some code here that's going to allow me to pass something like printline in as a function. So I'm calling this input parameter f, and then in this particular case, I'm going to say it transforms an int into a unit. And that's the way we define a function as an input parameter, is this code right here. And I'm saying that this is a function that has one input parameter, and that's an int, and that function is going to transform that int into a unit. And now I write the method body, and I say unit here. I'm going to say equals, and then this will be the body of the code. And this is where the for loop comes in. So now I say for, and I'm going to do x in x of s, do, and so far everything's the same, right? This code is the same as this code here, but where this code was calling print line, my code down here is a little more generic, and it's just going to call this function that I declared. So it's the function named f, and then I have to pass, x into it. And there we go. So this is our own definition of our own for each function. And now I could say for each with my own function here, I want to pass in ints, which I defined previously, and then I want to pass in print line as the function to use. And voila, you see that we have that right there. And one thing I could do to make this a little more clear is say, let's see, how do I want to do this? I will say, so for x in x of s, do print line. So this is going to just be a little debug output right here. So I'm going to say, we can even say debug, and we'll say x equals $x. And then after we have that debug output, then I can apply the function to each element, x. So that should work. That looks good there. And now if I go back to the for each here, you'll see that output. So I don't know if that helps, but since this is the first time in this course that I'm showing how to pass a function in as an input parameter, I thought it might help to just kind of expand this for loop a little bit. So what I do is, again, I iterate over all the x values in x of s, and then for each one, I print the debug output, and then I call the function. Whatever function you pass in, I call, and I pass your function the variable x. And so far, I've just been showing print line, but another one I could do here is print. And that's a little ugly with that definition there, isn't it? So let's go back to, let's use this function instead. And now I'm going to use print here instead of print line. So first I show print line. That's what print line looks like. And now I can pass in a print function, and you see that it works differently. Print line prints each one on a different line, and then print doesn't use a new line character afterwards. So all I'm trying to show here is that I can pass in different functions. So I can pass in any function that looks like this guy right here. So print line matches that, and print is another function that matches that. And I mentioned that we're already in bonus territory showing this because this is pretty advanced for a introductory course. What I want to do is we'll go into double overtime, I guess, here. And what I would need to do, I need to clear the screen is what I need to do. Okay, so what I want to show here, and this is an important lesson that goes way beyond anything to do with for each and anonymous functions, is that this body, if you look at the body right here, there's nothing in that highlighted code that depends on x or x of s being an int. And what I mean by that is I'm not calling any functions. Like if I had called a function right here on x, oh, here, let me just do that. Okay, so that makes an assumption that x is an int or a numeric value right here. But since this code doesn't have that, none of this code here depends on x being an int, what I can do, sorry, I had a REPL issue, so I'm going to go ahead and do that again. So what I'm doing is I'm getting rid of all these int references, basically. So we say, I don't care about ints. This can be any type because I don't refer to that type inside the body. And this is the way we declare generic types in a Scala function. So what you do is, the first thing you do is you specify the generic parameter or parameters over here. So we use A as the first generic parameter. In Java, they use T as the first one, then they go TUV. In Scala, we start with A and then we go ABC. So I am saying I want to create a function. Its name is foreach. it's going to use a generic parameter, which I'm naming A. The first input parameter, I'm naming x of s. It is a sequence, and I don't care what's in that sequence, so I'm going to give it the generic parameter A, the generic type A right there. The second input parameter, I'm naming f. It's going to be a function, and you really don't have any way of knowing that yet, but this is the syntax here that describes a function, so I do know that, and we'll discuss that more as this course goes along. But the second input parameter is named f, and it's going to be a function, and it's going to be a function that takes one input parameter. And again, I don't care anything about that parameter because I don't reference it here, so it can be the generic A. And the only thing I care is that it's going to transform that into the unit type. So because f here is the last thing that runs here, that means that that's going to be the return value from my function, and that's where this unit type comes from here, is this application of f of x there. And then I didn't change anything in the body here. So you can see that that compiled just fine. And now I can pass in ints again. Oops, I'm sorry, I need to pass in ints and print line. And that works just fine. I can also do a vector, and I would say we'll just stay with just that. It doesn't need to be anything too big, right? There's a vector. And then what have I done so far? So I did a list vector. I could also pass in a seek, and this could be a seek like of string, so I could do that. And you see, each time I call foreach, I can pass in a different type as long as it's a subtype of seek. I can pass that in. So a vector is a subtype and a seek is a subtype. And I also use integers here. And then in this one, I use strings. And the cool thing is that the foreach function works for all of these because I'm saying here, all I'm requiring is that you pass me a seek, and I don't care what's inside that seek. I'll pause. I was going to start adding some more here, but I'm actually way off script here, so I'm just going to stop at this point. And I say that I'm way off script because this is really just supposed to be about the foreach method and anonymous functions, and I did demonstrate that. And then what happened here was I kind of got into a bit of an excursion, and I got into how to actually implement a foreach function like this.